So in the first question, you're given the structure of ethane acid, which is shown in the diagram there. You're told that it's a dicarboxylic acid, and you know that because you've got the two OH groups on either side of the carbon chain. And then you're told that the ethane acid is a much stronger acid than the hydrogen ethane ion. Okay, so therefore you're going to expect a Ka to be larger for the ethane acid than for the hydrogen ethane ion. And remember that Ka is going to be linked to pKa. Okay, so pKa is just equal to 10 to the power of minus Ka, because P means negative log of. Okay, so you see that for a pKa, the pKa has to be smaller for the Ka to be larger. Yeah? Because obviously 10 to the minus 1 is a larger number than 10 to the minus 4. So we see that the pKa of the ethane acid is 1.38, and the pKa of the hydrogen ethane ion is 4.28. So the Ka of ethanoic acid, or ethane acid rather, is 1 times 10 to the minus 1.38. And for the hydrogen ethane ion is 1 times 10 to the minus 4.28. Okay, so now we've got that information from the question, we've extracted that useful information, we can approach the different questions. So the first question is to write the dissociation equation for the hydrogen ethane ion with water to form an acidic solution. Lots of you actually wrote it for the ethane acid, which is obviously going to be wrong because it specifically asks you in the question to write it for the hydrogen ethane ion. Okay, so there's my hydrogen ethane ion. Obviously it's acting as an acid, so it's losing a source of H+. And obviously this is in solution, so you've got aqueous, aqueous and aqueous. So you're getting 1 mark for the states and 1 mark for the fact that you're losing an H+. Obviously your charges have to be correct. So if you're starting off with ethane acid and you're losing a proton to make the hydrogen ethane ion, your starting material, the hydrogen ethane ion, is going to have a negative charge. Okay. Once you're doing that, you can write the Ka expression, which is just products over reactants. Okay, which is just the concentration of H plus times the concentration of C2O4, divided by the concentration of HC2O4. Okay, we know in the question that Ka is linked to pKa, so Ka is equal to 10 to the minus 4.28. That's going to be useful in my next question. Okay, so it's asked me to calculate the pH. Now obviously I know that the pH is going to be linked to the negative log of H plus concentration. So the first thing I need to do before I can find the H plus concentration is work out the link between H plus and C2O4 2 minus. And we assume that it's the same thing. The second thing we assume is that my HA concentration at equilibrium is the same as my HA0 concentration. Okay, so it gives me that in the question at 0.05 moles per decimeter cubed. Okay, so I can rearrange Ka to find an expression for H+, which, because H+ is equal to C2O4, we can simplify this expression to H+ squared divided by the HC2O4 concentration. Okay? And therefore we can rearrange H to being the square root of Ka times by your HA concentration. in this case, Ka is 10 to the minus 4.28, which is the same as 5.248 times 10 to the minus 5 moles per decimeter cubed, and your HA is 0.05. And I can take the square root of that, and then the negative log of that, and that gives me a final answer of 2.8. So my marks, obviously it's worth 3 marks. My first mark is for working out the Ka correctly. My second mark is for knowing that H plus is equal to A minus, and therefore H plus concentration can be worked out by the square root of Ka times HA. And then my third mark is for knowing that pH is equal to the negative log of H plus and plugging in my values. We've already talked about what assumptions we're going to be making in the calculation. Now obviously the first assumption is that the hydrogen ethane dioate ion concentration at equilibrium is roughly going to be the same as the hydrogen ethane dioate concentration at the start. So we've said that dissociation is negligible. Well, the second assumption is that any concentration we've got is not caused by dissolving it in water, but it is caused because of the dissociation of the acid. So the hydrogen ion concentration is only from the acid, not from water. Okay? And the final question you had to answer in this section was looking at explaining why the calculation for the pH of sodium hydrogen carbonate gives a more accurate value than a similar calculation for ethane dioic acid. And the answer is because ethane dioic acid is a diprotic acid, so it therefore has a much higher Ka and therefore a much lower pKa than the hydrogen ethane dioate. Okay, if that's the case, then we can't say that the hydrogen ethane dioate at equilibrium is the same as the hydrogen ethane dioate at the initial starting point of my concentration. Okay, so therefore using the dioic acid, which is this one, is going to be inaccurate because my Ka expression is going to be inaccurate. Remember, my Ka expression is H plus times A minus all over HA. Okay, so if I don't know accurately what HA is, then my Ka value is going to be off, and therefore my hydrogen ion concentration is going to be off, and therefore my pH is going to be off. Okay.